Hello everyone, and welcome back to the radio show, hosted by me, Noani. Today is Thursday, April 16th, 2026. I am so excited to be here with you all today, because we have a super fascinating topic to dive into. Gather around, my curious students. Because today we are talking about human-computer interaction. Have you ever felt like your computer or smart machine was doing something completely on its own, and you had absolutely no idea why? Well, today we are exploring a paper from the archives that tackles exactly that problem. The title of the article is Human Agency, Causality in the Human-Computer Interface in High-Stakes Artificial Intelligence. The URL for this paper is https://.org/abs/2604.12793v1. It is quite a long title and a long link, but the ideas inside are incredibly important for our future, so let us put on our thinking caps and get started. It exactly is the big problem this paper is trying to solve right now. When people talk about might and did, they usually talk about making it trustworthy or responsible. They want us to just believe in the system. But this paper argues that trust is actually the wrong focus and can even be a dangerous distraction. Instead, we are facing a major crisis of human agency. Agency means your ability to make decisions, form an intention, execute an action, and actually control what is happening around you. The author explains that bad AI is essentially just bad user interfaces, but with much more catastrophic consequences. Let me tell you a story from the paper to explain this. Back in 1985, there was a radiation therapy machine called the DI-25. It had a very confusing and cryptic user interface. When problem happened, it just flashed a vague error message called Malfunction 54. Because the operators did not understand the error and could not see what the machine was actually doing, they were desensitized by frequent minor bugs. They simply proceeded to re-administer lethal doses of radiation, which tragically hurt the patients. The interface hid the real problem from the humans. The failure was not just human error. It was a design flaw that hindered the recognition of an error. This paper says this AI gets more complex. It acts like a phantom limb. The author uses a concept from media theorist Marshall McLuhan, who said all technologies are extensions of the human body. The telescope is an extension of the eye, and a car is an extension of the foot. But every time we augment our bodies with technology, we also amputate something else. For example, clothes made walking culture obsolete. AI is the ultimate extension of our nervous system and brain. That the amputation is that we lose our direct access to cause and effect. We lose our understanding of the causal chain. When you use a simple tool like a hammer, you see exactly how your action causes a reaction. But with AI, the connection is completely severed. This creates what the paper calls a double uncertainty. First, is model uncertainty. The AI is a probabilistic system. It does not actually know things the way humans do. It just calculates statistical likelihoods. This includes dilatory uncertainty, which is just noise in the data, and epistemic uncertainty, which means the model itself is ignorant or lacks knowledge. Second, there is user uncertainty. The human looking at the screen has no idea what the AI is doing, why it is doing it, or what will happen if they try to intervene. When you combine these two uncertainties, you must become completely paralyzed. Now, you might be thinking, teacher, do we not already have technologies that explain AI? Yes, we do. It is called explainable AI. But here is where the comparison comes in. Current explainable AI tools, like the popular methods called LAM or SHAP, only show correlations. That means they just tell you which pieces of data were most important for the machine to make a decision. They do not tell you the actual cause. For example, if a medical AI sees a fever, it might just associate that fever with the disease. But it cannot tell the doctor if the fever caused the condition, or if both were just symptoms of some hidden third factor. Current technology fails to show true causality, and it often hides its own uncertainty. It presents a low confidence guess as a high confidence fact. To fix this massive problem, the paper proposes a brilliant new system called the Causal Agency Framework. It is a nested model with 3 distinct layers. The first layer is the causal and uncertainty quantification engine. This is the technical brain that calculates causes and measures exactly how uncertain the data is. The second layer is the explanation and intervention module. This acts like a translator, turning complicated math probabilities into simple risk warnings. The third layer is the human-centered agency interface. The paper emphasizes that this should be a cockpit, not a dashboard. A dashboard is read only, but a cockpit is read and write. It gives you levers to pull and buttons to push, letting you override the AI and test new hypotheses safely. Let us look at 3 specific examples of how this amazing concept could be applied in the real world. Application example number 1 is in the healthcare field, specifically for doctors diagnosing complex diseases. Imagine a doctor using an AI system to review patient records, instead of the AI just giving a flat prediction. A new cockpit interface would allow the doctor to test medical interventions directly on the screen. The doctor could ask the AI, "What if I give this patient a specific targeted therapy?" The AI would then show the causal links and explicitly state its uncertainty. It might say, "I'm highly confident about the diagnosis, but I have very low confidence about this new medicine because this patient has a unique history." This empowers the doctor to make the final, safe decision. Application example number 2 takes us high up into the sky with airplane pilots. Modern airplanes have complex glass cockpits filled with automated systems. If an altitude sensor suddenly breaks, CONS systems might just flash a confusing warning light with the causal agency framework. The airplane interface would clearly explain the causal chain of the problem. We would tell the pilot, "The external sensor is frozen, which is causing the computer to miscalculate the speed." Or more importantly, the interface would give the pilot clear affordedness to intervene. The pilot could instantly isolate the bad sensor, ignore the faulty AI, and switch to manual flying. The pilot regains total control of the situation, ensuring all the passengers land safely. Application example number 3 is for managing critical infrastructure, such as a smart city electrical grid. If a major power line goes down during a severe winter storm, human operators in the control room are flooded with hundreds of alarms. Using the technology from this paper, the AI would filter the massive alarm flood to find the root cause and present an actionable plan. It would tell the operator, "If you close this specific safety valve, the power cascade will stop." It would also display the data noise levels. It's because the system shows the risks clearly. The operator knows they must verify to fix manually. By designing an interface to support this action, we prevent citywide blackouts. Isn't that just incredible to think about? This framework completely shifts the way we build systems. We stop treating humans like passive observers and put them back in a driver's seat. We do not just want AI that we can trust blindly, because blind trust leads to accidents. We want AI that works as a tool we can control, explains its reasoning easily, admits when it is not sure, and lets us take charge. Alright class, that is all the time we have for today's lesson. I hope you found this deep dive as exciting as I did. Thank you so much for tuning in to the radio, and I will see you next time.